Okay, good afternoon. I am Anto Budiarjo. Welcome to Monday Live. This is something that we do every Monday afternoon at 3 p.m. Eastern as we try and figure out the future for smarter buildings. It's really good to have you with us today. In case you're wondering who we are, our profiles are listed on mondaylive.org. And just also to note here that views expressed here in this hour are personal, not of any company or organization. Just please keep that in mind. And let us make this as interactive as possible with us using the Zoom chat. It's always a lot better when we do that. And if you want anything that's on this slide deck, it's available on mondaylive.org. So this being June of 2026, we have been talking about readiness, general readiness for whatever the future brings. And it's been quite an interesting month so far. We're going to continue that. So our agenda, our normal news and trends chit chat, and then we really want to talk about readiness from the perspective of being ready for AI at the edge. That's a very specific sort of formulation that we want to talk about and have a discussion around. But before that, as always, I'm going to hand it over to Ken Sinclair for news from Automated Buildings. Over to you, Ken.
Thanks, Anto. I think we picked a very interesting topic, the AI native at the edge. It kind of is a different approach because we've always been talking about AI and we're applying it to the central controls we have. But when you think about it and you apply it to the edge, and just before we got online, Anto and I were talking about what is the edge and where is the edge. I kind of believe in my edge. It's you can define what you want. You can pull together a bunch of sensors and a rooftop, and you can say that's the edge, or you can pull against a bunch of sensors in a chilled water plant and say that's part of the edge. What I'm really looking for is that we are excited about is that we can give this edge an AI identity, and with its own processor, it basically is distributed and takes some of the load off of some of the projections for how much power AI is going to use in its central form. Certainly, it will be lower powered if it's done from the edge. So there's some exciting thoughts there. I think also it gives us the chance to embed kill strategies that if no matter what AI decides, you can't do that because it physically is beyond the capabilities of the equipment. And I think that gives us a safety. So it's it looks like a method that we can introduce some governance from the side. Anyway, I've in my trying to understand what that might be, I've poked around with Gemini, and we've come up with a couple of definitions, actually three, that we go through. And yeah, there's some real interesting thoughts. Kind of almost as like a brand new approach to what we were doing. Below that, we've got the summary of last week's Zoom call, which is the case for AI and native in buildings. Case for AI native buildings, all in one word. Another article that we had in our discovering of what we're doing in the future, we always unroll the picture that we haven't anywhere come close to completing the path. And one of the things that has been brought up is the IP4, IP6 thing that most of what we're doing is still on IP4, and there's a lot of benefits in moving to IP6, especially as we start to use more complex networking, such as in the BACnet AI approach. We've got this summary of about 4 or 5 articles on AI native that clicks off of that big eyeball there. The other one, unleashing AI in the buildings, there's a whole bunch of opportunities, and actually operating at that level, I think, has some advantages. And I think we have to take a look at what other industries are doing. And for other industries, their center is not a building. Their center is a robot or a manufacturing table or all kinds of various devices. And it's very interesting how they're interfacing all of these sensors and how they're starting to use AI. So I think industry can teach us a lot, and they don't have such precious standards as we do. So they're able to, where it makes sense, move to AI standards. So there's a lot of movement going on in that area. The other thing that I found in poking around with this is understanding how some people say it RISC-V and others say RISC-V, fuels AI native. And what this is it's kind of like a description of how the software works. And we need to actually start changing the hardware, which I found kind of intriguing because we've focused on open software, but we really need to have more open hardware. And the reason for that is that, of course, AI doesn't use browsers and doesn't use any of the methods we use to look at information. It just goes directly to the knowledge graph. And so therefore, it needs a different chip flow to make that work. And I'm kind of proud in the fact that way back in 2019, we actually had a session at AHR and where we talked about open software and open hardware and how that would set the future. And so that's a little bit of foresight there. We had a panel on that, and we got the room was absolutely chockers, and I think it takes something like that to change our thought pattern. But I just want to read the last, or have you read the last lines there, that the best way AI can teach edge is by emphasizing the philosophy of physical autonomy. It shouldn't teach students how to build devices that rely on the cloud. It should teach them how to build pieces of silicon that can sense, reason, act entirely on their own, right where the data is born. I think that's the shift. I think is a good thing we can talk about today. Back to you, Anton.
Okay, thank you, Ken. I think you're teeing up some interesting things for us to talk about. Over to you, Rick.
And I'm muted. And I think I didn't update the slides, so we can kind of go through these pretty quick. But I think the AI at the edge and the AI readiness at the edge is a big part of what what the working groups are working on, and the future stack and the future technology being, quite different than the past technology. I mean, like, duh. But that's where things are going, is more distributed processing, distributed technology, and distributed capability. And the edge is obviously a big part of that. So we'll be trying to weave more of this AI at the edge into our narrative about C4SB as we go forward. But if anybody's got any questions about, we will have the next town hall in July. I'm not sure what the first Thursday of July is. But if anybody's got any questions or wants to have this what we're calling the 2-page prospectus, shoot me an email and we'll get you more details.
Okay. Thank you. Thank you, Rick, for the update. Anyone else with any updates or news or anything they want to share?
Quick update from me. Yeah, there's a USGBC session this week that focuses on PAE, but it's about ensuring trust. It's related to how do you trust the data and how do you trust the information and how do you trust the building. That's on Wednesday. And then there's an upcoming ASHRAE conference in Austin and end of June, beginning of July, that there's a whole PA session on that as well too.
Okay, thank you. Can you put some links
in
the chat?
Yeah.
Thank you. I'm hearing nothing else, so let us proceed. to Readiness. So far this month, we started talking about readiness, and Kimon mostly spent that Monday talking about the readiness that's sort of going on at PAE and the various sort of angles, and that was very interesting, and it started really sort of the conversation going. Last week, we were focusing on the readiness of being AI native. So the whole concept of AI native is something that is just inherently is able to talk AI without much additional work. So that was again very interesting. So now we're going to talk about AI at the edge. So the question that Ken and I have been chatting about this on the before we got on air, but I'd like to sort of expand this to the group. When we say AI at the edge, what do we actually mean the edge? What is it edge of? So we see a picture here with a building with a whole bunch of devices. Some of them are, literally out in the very sort of extremities of the network. Some of them are in the building itself. And there's obviously a whole bunch of devices that you can't see that's sort of in plant rooms and whatever. And then there's obviously the cloud, which is indicated here. Obviously, the cloud is not the edge. I think we're clear about that. But what constitutes a cloud, and are all of these devices edge devices in our sort of definition here? So I'd like to spend a few minutes just to talk about the definition of the edge first. What do you guys feel is the way you can differentiate the edge versus the not the edge, whatever that is?
So I can start with that. Typically when we talk about edge, the first thing that comes to my mind is something that's on-prem, right? On-premise. And on-premise can look different depending on what the building is or the campus or the facility. It might not be necessarily something in every building, but something that's central for a campus, for instance. But more and more, what we're starting to see is as manufacturers push AI capability closer and closer to the edge. I think what a lot of people think of is some kind of a little embedded Raspberry Pi or Dell computer or something on-prem that's running AI because it has an AI capable board or GPU embedded in it, or just running software. But what we're starting to see more and more of is AI-like capabilities being pushed out to devices even, right? So when we talk about this today, I think we need to think it's not just a computer at the edge running or on-prem running local AI, but it's starting to push past that into individual devices and equipment even, right? Built in directly into equipment. And I think that's going to be the trend as price and availability comes down, size comes down, power memory requirement comes down. So
you're saying that it's a device that is connected to some physical activity that is the edge?
yeah, I mean, it can be to the edge of a building where you have a gateway-like product that's talking to systems or sensors or controllers out there. But, embedding AI capability into a programmable controller is not a stretch of the imagination at all, where it could be making decisions about how to run a piece of equipment right there on the spot using AI-like capabilities. And then being connected, it has the ability to share or consume in whatever it needs to do those calculations, for instance.
Could one
Others with
edge
thoughts?
identity share information with another edge identity?
Yeah,
I
it
think
could. Absolutely.
Why
Absolutely.
is it that could or it must be able to? Is that the way
Um,
that needs to be
Must.
framed?
I don't know that it must necessarily. I mean, I could see standalone applications that are running routines that are based on trained data, right? And that's all built into that device. I don't know that I
So
see a lot of
maybe
the,
it must. You're saying that some things just don't need to be shared, right?
yeah.
But maybe it must be able to share.
Yeah, I mean I think that the most common use case for something like that would be if you've got a controller that's right at the edge and it's running a big central plant and doing optimization right there on the spot, it is connected still and sharing data back out to quote unquote a cloud of some kind. But a lot of that calculation and so forth is being done right there on the spot, right? So I think when we talk about this, just keep that in mind that from what I've seen, the direction of all of this is to push further and further to, more distributed AI, further and further to the very last
Right.
device out there,
Yeah.
right?
Other
Yeah,
thoughts?
I agree with Tracy. The I have some because I'm associated with ISMA. I have appreciate a little bit a topic at least to bring up with regard to the if you will the next generation in hardware architectures, okay, and why this matters for this whole AI discussion. So what ISMA decided a number of years ago for its what edge devices, edge controllers, think unitary controllers, VAV, heat pumps, air handlers, things of that sort, right? Instead of going with a traditional microprocessor-based design, they decided to go with microcontrollers. So microcontrollers is where it's at. So think Apple Watch. That's a microcontroller, right? And they're less expensive. They have a lot of attention from the tech community now, so they're getting their power of microcontrollers for what they can do and how is accelerating way beyond what has been traditionally available under microprocessors. And because a microcontroller doesn't need an OS, so you have a lower cost physical piece of hardware that doesn't need an operating system, yet can run complete code that you would need to run to manage a device. And so because of its cost point, now you can put a microcontroller in a smart sensor, not just a controller. So IoT devices with microcontrollers in them become very powerful and very cost effective. And that device can ultimately, as Tracy was implying, over time can have AI algorithms running in them. Okay. So yeah, I believe it's a game changer in terms of how we think about edge. I don't know, I'm actually don't know of what's going on with the other companies in our industry with regard to adopting microcontrollers. I can just tell you what is going on in my world. But what I've learned about microcontrollers in this recent period of time is why they're having a fundamental advantage to 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 this whole edge discussion, and it's a worthwhile element of the full technology stack that we talk about is the hardware piece and the possibilities and potential for microcontrollers to really take edge down to an individual device.
I think that's great input, Steve. When I was digging around, that came up really as a big issue, is that the people, all of these devices, the whole Bluetooth thing, I mean, you touch it, it talks to you, it connects you, it does all of that stuff.
Right.
It's all done right inside your earphone. And
Mhm.
that whole technology is actually quite mature. And it also the interconnection, people are actually building hardware sensors, and the one that we use the least, that everybody uses the most, which is vision from cameras, is like a no-brainer. And we
Mhm.
always avoided those things because we thought they were expensive, but they've actually flipped. And they've now become the cheapest way of doing things.
Another,
So open it up.
yeah, if I could, I just want to add one more element to this discussion. So microcontrollers can exist on multiple communication platforms. In particular, IP, whether it's traditional TCP IP or T1L, uh, it's perfectly compatible in that regard. And what that means now is you can have increasingly flat architectures, truly flat architectures, from the smallest device to large, if you will, gateways or middleware products like the Tritium framework. Okay. So all of a sudden, it's a completely flat architecture going forward. And yes, what do you do with existing MSTP or RS-45 devices? These same devices can act as essentially, as gateways. Essentially, they can take in RS-45 and then completely make it IP ready to be transmitted over BACnet or Modbus or MQTT or other protocols. So you're not limited in that regard just because you went with a flat architecture.
Steve, let me ask how definitionally you're differentiating between microprocessors and microcontrollers. And we've been networking both microprocessors and microcontrollers for 40 years,
Yep.
and it's the basis of basically all building automation networks. I would say that most of the processors that we've networked over the years have no operating systems.
Mhm.
So what's the revelation? What's new and different about using microcontrollers versus microprocessors, or how would you define the difference between the
Yeah,
two?
the big difference is the cost and the not needing to put an OS on it.
Right.
Right.
The immediate problems that come up is maintainability when you
Mhm.
go down these paths. And the same thing goes for when you put AI out there.
Right.
How are you going to update, modernize, maintain these systems over the very long term? So I absolutely believe it's an inevitability, and I
Yeah.
agree with Ken that, if I want to put a camera watching mold in an air handler, that's something I couldn't afford before. It's something I can't afford not to do now.
Mhm.
They're great applications and lots of great stuff coming. The question I look at, having been burned by being in this industry for so many years, is how do you get this stuff to sustain over the long term? As we push stuff down to the edge, how is it going to be maintainable, sustainable, updatable, etc.?
Well, all I can tell you, Jim, is we have no issue. ISMA has no issue with that. We're upgrading our installed devices every quarter, and it's easy. You can do a mass upgrade to hundreds of devices in one shot.
Mhm.
So the technology that we've developed, it has no limitations in terms of keeping the stuff current.
Mhm.
Our original gateway was that had a microchip microcontroller in it, and we used to do mass updates all the time with
Yeah.
that. Yeah.
I think the other thing that's happened here, Jim, is you always talk that we had a scaling problem. We never really built enough things to ever have develop our own technologies. And I think what's happening here in my mind is because of things like watches talking to your phone and phones talking to everything else, and all of that's going on and it's accepted, and there's products out there that are specially built. These they take your heartbeat, they take everything, as all these things are sensing. And these are being built in the scheme of millions, which was always the scale you were looking for. And I think what's happening now is we're coming across the floor and we're saying, holy cow, this isn't really all that much different than what we're using. And if we stop thinking in human terms and start thinking like AI native, and we can kind of move right through some of these hardwood platforms, we can piggyback on that. And there's a whole bunch of incredibly cheap sensors that are incredibly powerful. I mean, your car and, LiDAR and all that stuff, that's all these new products that have just become standard. Take a look at the auto network. So all of a sudden, we've actually cracked the code We don't build enough thermostats to build our own thermostat. We don't really care. Other people have reasons for monitoring temperatures and batteries and all kinds of things, and they monitor temperature by thermography. They don't actually touch stuff, which is a trend now in as I understand in these large data centers now is you're not allowed to touch the silicon or get close to it. So they do everything with thermography. So it's thinking different and piggybacking on technologies that are there, which raises the question as we move across the floor, how much of our old standards do we want to use? Because if some of the new standards have knowledge graphs and all of those new tools built in, then we maybe just want to go on. So I think it's a time to shake our heads and take a look at who's leading the industry and what are they putting inside their processors.
There's some interesting comments on chat on this from Al and from Ron Bernstein. But I was going to ask you, Anno, from your perspective, what makes an edge device an edge device as opposed to not being on the edge?
Well, the glib answer is right. It's not the box that takes internet and converts it to whatever protocol you do. I mean, that's been the term for an edge device, right? In our world, it means a lot more now. It means, especially in the context of AI, can I put an AI agent or can I put a small language model in that edge device itself, right? What other things can it do beyond just translate, or transfer points, data up and down?
So edge is really meaning it's connected to something. It's connected to some physical
Yeah,
thing,
I mean, it's an
sensor or
IT
whatever.
term, right? I mean, it comes from, it's well entrenched in the IT space that says that, I've got all my servers in the server room and in the cloud, and then remotely I've got some box before it goes on to the next set, and there's an edge device there. It's been around for a while, the term. I mean, it's not a new term. But I think it's kind of had a resurgence in the AI world about, can you put edge technology on the edge box itself? Do we have to transfer everything? Can we do? And then you look at what NVIDIA is doing with their, what do they call it? The Jetson, Orion, right? I mean, they're pushing out a one GPU $250 edge device, right? Because they see the edge space. That's something very interesting and compelling as they saturate everything else. Why not?
Okay, so that was kind of anybody else have any thoughts on edge or not edge? And we can move on from there.
I don't think it's either or. It's not. So it's not. We're edge to the cloud and back, and that's the way it works. Like you can't, to Albert's earlier comment on, like you're not gonna your edge device or controller, microcontroller or BAS is not gonna hook to your GitHub repository so that you can verify that you're SOC 2 Type 2 compliant. Like that's just not going to happen. So there is no going forward without the cloud. You need SOC 2 compliance. You need security posture. There's security posture. You don't have access to other enterprise systems like NOAA weather stations, accounting systems, billing budget, all that stuff. So yeah, it's definitely not. I mean, us operating without the cloud, impossible. Like everything's done in the cloud. The edge device for us is just a transmitter that queues up and pushes data, the telemetry up, raw telemetry up. Everything else happens in the cloud. It gets normalized, categorized, all that stuff in the
Yeah,
cloud.
I think I call it as it's a fuzzy edge, right?
Yeah.
Okay. It's not black or white. It's a fuzzy edge.
Yeah.
So when we're talking about AI at the edge, I think Ken was sort of implying that means that it is completely whatever that edge thing is that AI is running at the edge is completely disconnected to the cloud and cloud-based
Oh,
AI.
I don't buy that 100%.
That's
No.
not going to fly.
I mean, so to
Yeah.
get to the extreme I was talking about the other day, right? Like last Wednesday, where we're dealing with a partner who is doing how do you get readings from a crack unit in the data center that you can't touch, right? You can't open the door, you can't put wires in there, you can't put Wi-Fi in there. So there's a preponderance of now of camera technologies, cheap cameras that you can put in front of a dial, and you can put AI at that level today, right? My cat door has that. I've got it. My bird feeder has AI at that point. Um, so, but at the end of the day, that bit of information, that data that it's interpreting at the edge and doing the visual interpretation of whatever the dial's reading, still has to go somewhere to be of use to somebody. And being contained in the camera is not going to help you. So, but the difference is I'm not sending the raw video all the way up to the cloud to do the processing. I'm just doing video processing at the edge in the camera and then getting the reading, and I'm sending the reading up to the cloud to go to the next.
It's a bit stream. It's not even video anymore. It's not point data. It's not video. It's a bit stream that goes up to the cloud and is analyzed. It's a
Well,
packet.
these guys were doing that right at the camera. Keith, are doing that all that.
Yeah. I know it could be done. Yeah.
Yeah, and they were doing so they were sending time series data streams based on it just reading just as if you had some guy sitting there saying
Right.
22, 22, 21.
Uh-huh. Uh-huh.
If you extend it out, though, I agree with both of your points here. In fact, that was one thing I was going to reinforce. It's really a combination of edge and cloud, even if it's an autonomous kind of a device that you can train and say, okay, you do your thing over here. But imagine a building of any size. As these device costs go down, you're going to have thousands and thousands of things happening. And at the very least, you want to know what they were set to do. So you don't just set them and walk away. It might change and say, well, I want to know what rule was embedded in this thing as the owner of the building to say, okay, why is it performing like that? Does it need to be adjusted? So even if they're completely on the edge, there has to be some, back to your original point, Anto, I think it should be that it must be able to connect, right? You can't just say, well, you can disconnect completely.
Yeah.
Some legacy systems might have no choice, but the newer ones, if the cost is so low, then it's connectable. Therefore, I can at least query and say what it's doing. And the more advanced ones, I want to even change things if the situation changes, right? So it's a combination of use cases, not one or the other. It's not like everything's on the edge or everything's in the cloud, like Keith and Anna, you said too.
I
So
think it's the
independent.
user gets to define the edge. And in the case of OEM, then it becomes much clearer. I mean, if it's a rooftop, then everything was delivered with that rooftop that got plopped on that building could be a AI at the edge. And we should, in that building, we would call it. And then where you have a situation like Anna was describing there, where with complexities, he definitely needs the cloud. And so I think it's the edge is what you say it is. Yeah, it's user defined, and maybe that's sort of the first comment that comes up when you try and use their edge, is it tells you what it does and what it doesn't do.
Yeah, I had another interesting use case just this morning. Someone was showing me again camera technology, and these guys were going to take on the HID card proximity business. They were putting edge face recognition right in the camera to do access control as opposed to prox card. And they were doing, it was actually pretty sophisticated stuff. I mean, they were doing not just individual recognition, but crowd recognition, tailgating recognition. Is one guy open the door and three people walk in, and they were doing all this in the camera on the door.
SoFi Stadium is doing that, and they've been doing that for years. There is no ticket. You have to opt in for facial recognition, or you don't go in there. And you have
Right.
to have everybody has a credit card that they give beforehand. You have to, or you don't go in. And you
Well,
walk through the door, it unlocks for you. You walk in. We went in, my wife and I went in to get some sweaters and t-shirts and stuff. And she said, we were like ready to pay. She's like, no, just walk out. You just walk in there, pick it up, try it on, and when you walk out, it gets charged to your credit card. And they don't give you the option. If you don't want to give your credit card and you don't want to opt in for facial recognition, you're not going to go see the football game or whatever.
Yeah. The TSA touchless now is like that too, right? You can do TSA touchless with it's all just face recognition. You don't have to have
Yeah.
a boarding
Yeah.
card. You don't have to have a
Yeah, I've been going to
ID.
using Clear for years. Yeah, Clear.
Yeah, Clear's the same. But Clear still had to hand off to the TSA guys,
Yeah,
right?
yeah.
But when I came into the US last week from overseas, that was the same. It was just facial recognition. I didn't have to show my passport or anything.
Yeah.
So anyway,
Yeah, but I think the point
on
I was making with the guys, the camera one was they were doing all
the edge.
all at the camera on the edge directly. It wasn't going to a cloud and processing. But having said that, and then it would open the door or not open the door. But having said that, there's still a lot of data we were sending to the cloud that was doing for subsequent analytics. How many people are towing, right? How many, there's a whole lot of other level of analysis that goes on that's not edge level stuff that's relevant.
I think that processing at the edge is hugely powerful and will gain a lot of momentum as time goes on. But I want to point out the fundamental word that describes what we've been working on for years. It's called a control system, where one thing controls another, where one thing gathers data or provides its enterprise management over a collection of things.
Yeah.
So I think that that's the reason it's always going to be both, is that the physical overall problems that we're trying to solve involve something controlling a collection of other things. And therefore, doing that in isolation doesn't provide the same outcome as doing it in a system. So,
yeah, that's why I think it's a fuzzy definition, right, as to how much you're doing. You could do nothing. It could be nothing more than a pipe, or it could be a whole bunch of processing. It could be algorithmic. It could be CPU based. And today it's moving a little bit into the AI space, right? It's on that. What's it, Vincent's statement?
Continuum.
That's right. There you go.
Yeah, I mean, I'm starting to see, especially as we kind of move into the realm which we're terming physical AI, we're very much similar to a car painting robot. In fact, we're even using iterative learning control frequency domain, which is exactly what a car. So the difference is that there's a car painting robot and it does the same repetitive task every day. It's only painting one type of car. So imagine if you had a cloud that would send down if you use a video camera to see what kind of car was coming down the line, and you downloaded the control process for each particular car on the fly in real time. That's exactly what we're doing with our AI controller. So when it sees different characteristics during the day, the outside weather, the load, whatever, it's downloading a process, a rigid, rigorous process for that moment in time. And it's like switching different programs into a car painting robot. Only it's software.
That's the Matrix, right? Load me how to fly in a helicopter.
That's what we're doing. I mean, pretty much. I mean, it's duplicating, it's allowing on dynamic programming control of a robotic machine in real time.
That's true, but I think back to Jim's point, right? At the end of the day, the actual painting exercise itself and the robot is done locally, right? It's the thing that you tell it what sequence and things that you need it to do, but the actual physical moving of the arm and the paint on and off is done at a local level. Right.
Yeah, but imagine if you could download a multiple local profiles to that machine, that robot, then it wouldn't be able to just, like, you take a motorcycle frame and put it on a car line, that thing's going to bump into it, destroy it and everything, because it only knows how to paint one thing. But what if you switch that profile dynamically down to it? Now it knows how to paint anything that the AI cloud sees coming.
So what you're saying is in our controls world, back to Jim's point, right? We have I'll pick something, VAV controller, right?
Yeah.
We have pre-configured the VAV to do one thing.
Static pit loop. Like that's what the cloud enables in moving from static control to dynamic real-time control.
And we did some stuff back in the day, like we did optimize start stop, but that was something that was telling us don't start at 6, start at 6:30.
Yeah.
So that's almost a limited aspect of what you're talking about, right?
Uh-huh.
You could, I'm guessing, and I'm putting words in your mouth. I mean, you could probably start looking at traffic patterns and
We're
all sorts
already
of.
doing that.
Oh, okay.
We're already doing that. Supermarket, we're looking at traffic patterns when people open and close the doors. Our system realigns the midday defrost cycle so
Yeah.
that you get a head start on the 9 degrees. Why let it open? Why let the temperature go up to 9 degrees or 10 degrees when people open and closing the door, and then push it back down to -10, and then the defrost cycle happens 2 hours later, and you go up 20 degrees. You are already there with the people opening and closing the door. That's a real application that we've developed for supermarkets.
Nice.
That's cool, but that's the same thing, right? At the end of the day, what you're doing is you're using the power of the cloud to push down the right model at the right time.
Absolutely.
So it's not really AI at the edge per se. It's AI working with the edge and
Being
everything else in
executed at the
concept.
edge. Yes,
It's
being
actually-
It's
executed.
really all of the above, Anto.
Right.
Yeah.
But it's got to be important. The edge still has to work if the cloud disappears.
Yeah, it just falls.
When's the last time the cloud disappeared, Ken?
Well, it's going to.
Restaurants, it happens all
That's a whole nother thing. I mean, the cloud
here's
doesn't
the-
disappear, but I mean,
Well,
if
so
it
to
does,
the-
it just goes back to doing what it was doing before.
Well, it won't, but the new architectures,
will.
well, the new architectures. So we were talking about readiness, and readiness for the new architectures is kind of where my head is. And if we look at where 6G is going, the cloud disappears. Sorry, it's peer-to-peer. So the communications capability of device to device ain't going to go through a tower. It's going to go from peer to peer. So the new architectures need to accommodate that kind of new capability. And that's where it'll be nice to have a cloud, but you're all talking about a cloud that's a dedicated cloud to the app that you wrote. That's not going to be the expectation in the future. The cloud is going to be a cloud that's not a known host. It's going to be some unknown host. Now, how do you negotiate with your peer-to-peer capability to an unknown host capability, whether that's in the peer or whether that's on the internet or whether that's in the thing we used to call a cloud? That's what we need to be talking about preparing for, is your systems are going to need to be able to do peer-to-peer and to be able to communicate with an unknown host. And that's and be able to have an unknown host communicate with you.
That's a big part of Elon's new servers in the space model, right?
Right.
They are all microservices, highly distributed, handing off to whoever, wherever, whenever. You never know what machine you're running on anymore.
You can't
It's the
know.
same.
So
I got
the
news for
architecture-
everybody. It's the same with Azure right now. There is
Yeah.
no dedicated machine. It's an app
Yeah,
service.
you are handing off.
It passes your code off through the cluster, and it gets executed on any one of.
That's just Kubernetes. That's two generations
No, it's
ago.
not Kubernetes, Rick. It's called an app service. It's an
Okay.
app service. It's not
So-
getting deployed over and over. It's
So to be
running
able-
code. In fact, you actually get billed by the execution cycle. That's here today.
It's
in the-
Lambda. You're talking about Lambda.
Yes.
Yeah.
That's here
Yeah, so
today.
that'll be the expectation going forward of applications, is to be able to communicate not with the host that you designed, the service that you designed, but one that you did not design.
Been there, done
And-
that. Yes.
And to
No, but
do
that's-
that with
I'm sorry, but
full
it's not being done today. So that is
Okay.
it'll be a new capability.
and to do that with full trustworthiness and everything else and security that's needed.
Right. So that's where to be thinking about in terms of where's the puck going. That's going to be the new architecture, and it's just a couple years away. So the expectations of applications being able to leverage that new capability, incredibly new capability at the same price or lower, That's where when we're talking about kind of new tech stacks or new developments, we're trying to say be ready for that. And that's AI, distributed AI at the edge, a different kind of architecture.
Well, in our industry, that's what connection profiles, CNSCP, is trying to solve.
Right.
That is an approach that we are talking about in the industry.
Yeah.
None of that goes past the fundamental control relationships, the business relationships that we're looking to have, whether it's done in a cloud-centric arrangement, a peer-to-peer arrangement. You still have certain business problems that you're trying to solve where one thing needs to control or provide supervision to another. Whether those things are individual humans, whether they're AI agents, uh, something is in charge, something is responsible, something has to provide the root of trust. All of those things have to be built in, and I will not argue with you, Rick, that I do think these things are coming, but think of them in terms of the business context, not what we can do in terms of technology. I think that's a really important starting
And the
point, and
customer
I'll
doesn't
hold my
care about
ground
all
on
that.
that.
The customer doesn't care about all that. They care about
Exactly,
the
Keith.
value delivered. Like they don't care.
Well, but they're going to care when they have everything else working in a new way. And that's all I'm saying is that it's going to be the expectation. Does anybody disagree with that?
Yeah, I
I,
disagree with it.
I think
Obviously.
I think it's a time thing. I think today I I struggle with even trying to explain to a client what it is we're doing, right? So for them to even start to ask questions about, what the level of the detail is, that's the problem right now, right? So it's I get it, because we do it as well in the back end. And when I get dragged into those, client meetings and say, "Oh, explain your architecture and how all this works," I go, "Okay, who am I talking to?" At what level do I need to talk, right?
There,
Rarely do they bring in anybody who's
there,
got that level of
there's some
skills.
engagements where they've already settled mission critical customers like hospitals and laboratories, which we are engaged with. They've already determined what the architecture is going to be because they're not going to trust your whatever you're sending to and from the cloud. It's called Apogee. No, not Apogee from Siemens. It's called APIGEE. Anybody ever heard of that application? It's a proxy server.
Hmm.
So you create some JSON from a poll, you pass that to their Apogee instance. They sanitize it, push it up to a cloud which is in their domain, host it on their system. Then you crunch the result, and then it comes back down. They sanitize it again. That's the only way that we're able to operate in Kaiser Hospital, bioMérieux labs. That's the only way, and they've already defined that. We're talking about defining for the customer. The customer has already told us, you're not going to get on our network unless you go through our Apogee proxy server.
Wow.
So it's a known. People have been using this solution for decades in IT in mission critical systems. So that the architecture is already defined, and we can't even change it. We don't even have a say. We do what they tell us to do.
Yeah, I agree that's true for mission critical applications and stuff. When I wander into a commercial building, run by a guy, a little bit
Yeah,
different, right?
yeah, but that's not our call.
No, I know, I get that. But my point is, I still think it's a little all over the map, right? The guy I ran into in a commercial building, he doesn't have much of a clue. But I
No,
agree with you, mission critical stuff, and we do the same. Data center guys, right? They are mission critical infrastructure guys.
yeah,
They've got a lot of smart people that you talk to and know what they're
exactly. Yep, yep. Same thing with our data center customers. Like they've already we don't even come in with a FAQ or anything or architecture diagram because they're just going to say no,
doing.
no. This is the way you're going to do it. Okay. Yep.
So where does this leave us with readiness? And here we're talking about us as an industry and our readiness for AI at the edge. That's kind of the. I'm
I
just
I
reading the
don't even
breakdown.
think it's not an industry. this stuff is moving at such pace and such change. For us to be bold and say, here's what the answer is for us, is it's pretty ballsy. Because the moment we say it, it'll change
Very,
next week.
very arrogant. I mean,
Yeah, best we could do at the
we
moment
don't
is
know.
track what's going on.
But we do
And
know it's
advise.
changing. But we do know it's changing.
Yeah, that's key, right? Don't be blinkers on and say this isn't going to happen, and it'll be fine. And in fact, what was it, Ken? You came up with it the other day, right? Or was it last week when we were using the old adage of, it's not that AI is going to replace my job; it's a machine. Sorry, a person using AI is going to replace my job. Well, the same is true on the machine level, right? It's not that. I'm not going to go work with a machine that's not using AI. I'm going to go have a preference for people who are using AI already in their machines. That's a preference point now.
I think
But it's changing so fast.
another big picture thought on this is we all know that the systems we've got out there, the distributed systems, and I think Steve's been suggesting they're making some changes, but I think everybody's sort of sitting there. What will our next generation of software look like for what we are defining as our edge devices or our OEM devices, which may be a rooftop, maybe heat pump, maybe whatever. And so they're sitting there, they're trying to make that decision. And I think there's been some important points made here that it's moving from micro. I don't know, maybe we need Pico, or maybe we need some kind of different processors or something, but we're going to move, and they need to move to a different technology. And I think a lot of them are just sitting there deciding what that's going to be. And I think some of the votes is that it's going to be a Unix box. It's going to be, we're probably going to move to a more robust thing, and some of this different type of instruction set for the processor. So we're going to see open, and I think you're going to start seeing, I think you are seeing now in the industry that the people supplying these platforms are offering some pretty incredible capabilities. And so I think we just need to set some of the thoughts as to how much of this could be pushed, because by a definition, for a different reason, they're going to put in a more powerful processor and are going to put in a different processor. Once they have that more powerful, different processor, I think adding a lot of unloading a lot of the AI interaction is real easy, and we can also have AI drive that. And heck, it'll be a great sales tool, because this one is now AI. You take it out of the box, and we're getting more and more of that kind of thing. As you bought a new TV and it's Google ready, so you just hit it and you talk to it, and you're basically talking to Gemini. So that came with the TV. That wasn't an add-on. So we're going to see more and more, I think, of that kind of thinking happening right on the devices we're buying. And then because they've got the numbers, they're going to drive that technology down. And I think we're going to end up with pieces of TVs in our automation systems.
What
So-
that also drives is the readiness. If you go back to the readiness thing, if it's going to be at the edge, then we need to be precise about what that thing is doing at the edge. You're not just telling that edge device, go out to the foundation model and ask the large language model what to do. You have to have a precise
There you go.
instruction at that point, and what the relationship is to the other point, which gets into these knowledge graphs. Okay, why are you doing that? Now you're being trained to do this, versus go talk to ChatGPT and ask it what it thinks, which wastes a lot of resources.
It's less about the processor and the hardware, because that's going to be the right hardware and the right environment for the use case, whatever it is. If it's camera is one thing, if it's sensing something is different. It's not really about that, and that will continue to evolve in all sorts of different ways. We know that. But it's really about making sure that all of these devices can, when needed, share information and data.
Yeah,
with
and that's
with minimal hassle, with minimal risk, and with minimal effort.
Yeah, that we can do right now. That we can already start planning for. That's not going to change regardless of how it actually set up, right? So we don't have to wait to see what's going to be in the future. We could say, if we're more explicit about what these devices and systems are doing and their relationships in the building, then we can pivot to whatever technology, whether it's edge or cloud or small device or microprocessor or whatever. It's all, how do we capture those use cases and be explicit about the instructions?
I'm just gonna vibe code that whole application anyway, Kumon, and then if you want to change it, I'll just go back to the prompt and re-engineer it and
Exactly.
get it done tomorrow.
You have to know what the use case is, though. You can't just say, well, go figure it out for me.
But that's the real thing these days, right, guys? I mean, there's the 10x programmer guy right now, that the amount of things he can program and configure today using AI is 10x where we used to be, right? Just building stuff. So I can see people going like, do I really need to care about what all the use cases and possibilities are going to be in the future? I'm going to program the thing that I need right today, and tomorrow I can reprogram it and reconfigure it overnight, right? It's no longer a whole 6-month cycle. I mean, I'll recode it. I'll tell Claude to recode it. Okay.
David, do you have any thoughts? You've been very quiet.
It's kind of out of frustration, because I think the term edge isn't really relative anymore. And it's really just everything's on the network now. And before, compute was a challenge, memory was a challenge, bandwidth was a challenge. Now none of those three are a challenge. And so I think that, the concepts mentioned previously about like Rick talking about everything being a mesh network where things talk to other things instead of a core and spoke hub network architecture. I mean, that'll happen too, and it's more robust. But at the end of the day, when we talk about, I feel like the concept of an edge device isn't really relative anymore. And the reason I think that, when we were doing network design at my last firm, we either had dumb devices or smart devices. And a dumb device is a sensor that can't do anything but sense. And then that was connected to something that can do something and is usually networked to everything else. And so will we see AI everywhere? Yes. Will it ideally be able to work locally? Sure. Will it need to access cloud resources when it needs to? Yes. Bottom line, cybersecurity. And so I think that the idea of AI ready, really, I think it comes down to perhaps just your serialization language for your file format. Because if it's, a file format that can be read and put into, if it's Turtle or whatever, that can go to RDF, does that mean it's now AI ready? Sure, because it's using that kind of serial file format instead of maybe JSON. But AI ready, and, I really think what we're all coming to the realization of is that we're just going to have a massive abstraction layer so everything can talk to everything else. And, at the end of the day, if you want something in AI format, you'll just do a translation layer from your JSON to your Turtle or whatever, and then Bob's your uncle. So my hot take is the term edge almost doesn't mean anything anymore because of bandwidth, memory, and compute power being ubiquitous.
I think you answered the question that I asked at the beginning of the show. It's because it really, the edgeness of it doesn't kind of matter. I mean, because I think of an edge as being an edge of a table, so something can fall off. It's nothing like that. It's just all in one big mesh. It just happens to be maybe edgy.
I mean, edge mattered back in the day with maybe a wide area network, and you have these 7 things are using one 3G card as a gateway to get the data out. And so you needed to be very conservative because of bandwidth limitations or network bandwidth limitations. But those limitations in compute and memory are no longer there.
But going back to the OEM point, that you're buying this stuff, it's coming with AI in it. And that's going to happen because they need to do that to make their product. If we can come up with some rules as to how we can best use those products, thinking like rooftops and heat pumps and things like that. I think that's what I
think what David is saying is that you're right. Right. But as long as there is an easy and secure way of getting data, it kind of doesn't matter what you call it or what the thing
or
is.
where it is physically.
Or where it is, yeah. Whether it's actually in the room or in the cloud, it really doesn't matter. I mean, there are some nuances that may matter in some use cases, but in the main, it doesn't matter.
The edge is in
And I feel guilty for making us go over time. I should talk
I need to drop.
earlier. All right.
Okay.
I'll take all the blame.
We need to wrap
Mike.
anyway. All right, it's all David's fault. And so
Cheers.
we'll wrap on that.
All right.
Thanks.
Thanks, guys.
Somebody thanked us for the Discord.
Cheers, guys.
Bye.